Dear students, in today's class, we'll learn about property 2 of Laplace transform and important problems on property 2 of Laplace transform. So, we'll see the first example as Laplace transform of t into cos at, and second example, Laplace transform of t square sine of at.
Good morning, dear students. In today's class, we'll see problems on property 2. What property 2 says, if L of f of t is equal to f dash of s, then we have Laplace transform of t raised to n into f of t is nothing but what here? Minus 1 raised to n d raised to n upon ds raised to n of f dash of s, means nth derivative of function of s with respect to s we need to differentiate here. So similarly I can say that Laplace transform of, if it is n is 1, so at that time t of f of t, so here n value is 1, so what happens here? Minus 1 raised to 1 d raised to 1 upon d s raised to 1 into f dash of s. Means if n is at value t to the power is 1, only one time differentiation. Next is Laplace transform of, if t to the power 2 is there, so t square f of t is equal to minus 1 raised to 2 d square of upon ds square of f dash of s, means n, just you need to replace the value of n by 2 here because of power of t is 2. Similarly I will show one more. So Laplace of t cube of f of t is equal to minus 1 raised to 3 d cube upon ds cube of f dash of s. So like that this property number 2 will work out. So this is a differentiation uh, with respect to x, and power means the this differentiation will be depends, maybe it is first order, a second order, or third order, depends on what here, the power of t. So we have seen in the previous class e raised to at will be multiplied to the function f of t. At that time it is going to consider as first shifting, so this is a second shifting I can say, as well as a second property of our Laplace transform. If t is multiplied to the function, at that time what is going to happen? So based on this a small introduction, so I will see the examples. So what property says here, if Laplace of t raised to n into f of t, if t raised to the power n, if multiplied to out here function f of t, then it will be minus 1 raised to n, and nth derivative of f dash of s with respect to s. So what we have to do here, we need to differentiate, we need to apply Laplace transform to the function f of t. Then for that Laplace transform, if you multiply t to the power n, so that for the given whatever output Laplace transform will get, so that function of s will be differentiated according to the power of n with respect to x here. So we'll see the problems, it will be more clear now. Problem is, find the Laplace transform of t into cos of at. Solution. So here, so we need to find Laplace transform of t into cos of at. You can observe here t is multiplied to the what here function cos of 80. So I will say that here our function f of t is cos of 80. So once you recognize what is function, then we need to apply for what here? Laplace. Take Laplace operator on both the side. Laplace of f of t is equal to Laplace of cos of 80. So but Laplace of f of t, what we have taken here, it is Laplace of cos of 80 is equal to, so here the solution is, because of cos, it will become s divided by s square plus coefficient of t is a, it will become a square. So we got Laplace of cos 80 is what here? S divided by s square plus a square. Now we'll apply the we'll multiply t to the both side. So what happened here? So as we know that, so t to the power 1. So t to the power 1 means what here? So it will be minus 1 raised to 1, means minus 1 raised to 1 is nothing but minus 1 itself. So d by ds of f dash of s. So I will write here. So it will be Laplace of t into cos of 80. If you applying the second shifting property, it will become minus 1 raised to 1 d by ds of, this is nothing but, I can say that this is our f dash of s. This f dash of s is nothing but s divided by s square plus a square. So this is clear. So in place of f dash of s, we need to replace this, means we have to differentiate this with respect to x, so which is nothing but, so we'll go for the differentiation. So minus 1 raised to 1 is minus 1, and we'll differentiate this. So while differentiating, the numerator and denominator having a function of s, means u upon v. So we need to apply quotient formula for this. So what quotient formula says here? Denominator square. So I will write here differentiation of d by ds of u upon v. What is the result here? So we need to differentiate denominator v square, v into differentiation of u minus u into differentiation of v. So we'll apply this formula to the above concept, then we'll see what is the resultant here now. So therefore Laplace transform of t into cos of 80 is equal to minus 1 raised to 1 will become what here? Minus d by ds of s divided by s square plus a square. Now I will differentiate. So this is minus, will keep outside. So differentiation of s upon s square plus a square, denominator square, that is s square plus a square whole square. So s square plus a square will keep as it is. Differentiation of s with respect to s is 1. Formula minus. Then s into differentiation of now denominator. Okay, differentiation of numerator s upon with respect to s is 1. So now we have to, we will keep s as the differentiation of denominator as s square plus a square will be 2s plus a is constant 0. So therefore on simplification, minus, so denominator will be as it is, s square plus a square whole square, open the bracket, it is s square plus a square, because s square plus a square into 1 is s square plus a square, minus s into 2s will be 2s square. So on final simplification, we'll get what here? Minus outside only. So s square plus a square means s square minus 2s square will be minus s. So I will write a square minus s square divided by s square plus a square whole square. This minus you multiply for the inside function. So this will become what here? So because of this minus sign, a square minus s square, if you multiply, it will become s square minus a square. S square minus a square divided by s square plus a square whole square. But you can stop it here, or we can say that, so this result can also be elaborated, because we know that this may be s square minus a square will be s plus a, s minus a, but we don't have any term to cancel, so we'll stop it here. So this is the result of what here? Laplace transform of t into cos of at. So in this way we need to simplify the problems based on property number 2. So next example is, find the Laplace transform of t square into sine of at. So solution, so we need to find Laplace transform of t square into sine of at. So what happens here? So here t square is multiplied to the function sine of at. So here f of t is sine of at. So therefore take Laplace transform on both the sides. Laplace transform of f of t is equal to Laplace transform of sine of at. So Laplace transform of sine at is what here? It is a divided by s square plus a square. So this is the answer of Laplace of what here? Sine of at. So therefore, so we got the answer of what is Laplace transform of sine at. So once we got it, then we'll see what is t square. If you multiply t square, what happens here? We'll see. So now Laplace transform of t square into sine of at. So what happens here? The value of this one is 2. So therefore it will be minus 1 raised to 2 d square upon ds square bracket of, this is a function f of f dash of s, so it will be a divided by s square plus a square. So I have applied property number 2. So in place of n, replace what here? 2. So we'll get this result. So on simplification, so we know that minus 1 square is plus 1. So therefore this result will become 1. Then we need to differentiate this a upon s square plus a square twice. We'll see now. So we got this. So we know that here a is a constant. I'll keep outside. A into d by ds of a 1 divided by s square plus a square. Because this a I have kept outside, so d square upon ds square, I'll write d by ds into d by ds of this 1 upon s square plus a square. So see here you know that differentiation of 1 upon s square. So because a square is a constant, so we'll apply directly. It is a into d by ds of, so differentiation of 1 upon s square is how much here? It is minus 1 divided by denominator square, that is s square plus a square whole square, into differentiation of the denominator is what here? S square plus a square, in how much here? It is 2s. So therefore on simplify, or else you can apply u upon v rule also, that is quotient rule also, we'll get the same answer only. So I have applied here. So differentiation of 1 upon s square plus a square with respect to s is 1 up minus 1 upon denominator square into, here differentiation of the bracket term is differentiation of s square plus a square is 2s plus 0, so which is nothing but 2s. So therefore this a as it is, d by ds of, will get minus 2s divided by s square plus a square whole square. Now, so on we need to again apply what here, differentiation. So before applying this, minus 2 will keep outside, minus 2a d by ds of s divided by s square plus a square whole square. So here what happens, numerator also having s and denominator also having s, we need to go purely differentiation u upon v formula, that is 2a. Now denominator square again, so it will become s plus a whole square into this 2, it will become raised to 4, then s square plus a square whole square will keep as it is. Differentiation of s with respect to s is 1, formula minus will keep as it is. Differentiation of s square plus a square whole square will be 2 times this bracket, that is s square plus a square, into differentiation of inside bracket term is what here, differentiation of s square is 2s and a square is 0, so you will get 2s here. Chain rule you need to apply. So on final simplification, I will repeat. So s upon s square plus a square whole square will be what here, denominator square means s square plus a square, already we have square, if you square again it will become raised to 4. So denominator will keep as it is, that is s square plus a square whole square will keep as it is. Differentiation of s with respect to s is 1, formula minus, then this numerator will keep as it is, so s into differentiation of this s square plus a square whole square is 2 times this bracket, that is s square plus a square, and differentiation of this bracket, that is s square plus a square, is 2s. So therefore minus 2a, on simplification denominator will be as it is, s square plus a square raised to 4. So this is s square plus a square whole square will keep as it is, open this bracket. So minus this s into s is s square, 2 2s are 4, it will become 4 s square into s square plus a square. So in the numerator you can find two terms, this is one term and this is completely second term. In this term which all things are common, I will take it. So here denominator will be as it is, s square plus a square as it is, raised to 4. So among the numerator I will take s square plus a square common, because we have here 2 times, this is 1 times. If I take, so what left inside here, so I have taken 1 time outside, so 1 time is left, s square plus a square is left, minus 4 s square, because this is I have taken common outside. So this s square plus a square, 1 raised to power 1, s square plus a square raised to power 4, it will cancel with this bracket, will cancel 1 time from this 1 time. So therefore what left, I will rewrite minus 2a. So here this cancels, what left here, it is in the numerator, it is s square plus a square minus 4 s square left. In denominator, s square plus a square, 1 time cancel means 3 is left, raised to power 3. So again we need to simplify this, because s square minus 4 times s square will become what here, a square minus 3 times s square. So on simplification, so we'll get here minus 2a as it is, s square plus a square whole cube. So on numerator a square as it is. So this s square minus 4 times s square will become minus 3 times s square. So again you multiply this minus sign inside here. So it is 2a into, so numerator will become what? If you multiply, it will become 3s square minus a square, because if you shift multiply, this will become minus a square and this will become plus. So therefore plus times 3s square minus a square divided by s square plus a square whole cube. So I can say that finally, therefore, so Laplace transform of t square of sine of 80 is nothing but what here? 2a into 3s square minus a square whole divided by s square plus a square power 3. So this is a result of t square sine 80 using second property.